This is OCR's paper 5 from November 2020. It's the non-calculator paper, higher tier. And if we have a look, you need 18 marks for a grade 4, 29 for a 5, 41 for a 6, etc, etc. So question 1, and here we've got to write 75 as a product of its prime factors, and what we're looking for is a prime factor tree. So we're going to look for two numbers that multiply to make 75, and what we're really looking for is prime numbers, but we'll just pick any numbers. 3 times 25 is 75. 3 is prime, so we're going to put a circle around it. Two numbers that times to make 25. 5 times 5 is 25, and they're both prime numbers, so that's the end of the prime factor tree. Don't forget to write this as a product. 75 equals 3 times 5 times 5, multiplying, not adding. Question 2, nice little equation to solve. We've got 4x plus 3 equals 13. We're going to start by taking 3 from both sides, and you've got 4x equals 10. We're then going to divide both sides by 4, and what you'll get is x equals 10 over 4. That is fine to stop there, but 10 divided by 4 is the same as 5 divided by 2, which is 2.5. It does not say give your answer as a decimal, so I could have stopped at 10 over 4. Part B, we've got some brackets to expand and simplify. So I'm going to do 5 times 2x, and I'm going to do 5 times 3. 5 times 2x is 10x. 5 times 3 is 15. Look at the next set of brackets. We've got 2 times x and 2 times negative 4. 2 times x is 2x. 2 times negative 4 is negative 8. And that's the expand part taken care of. We now just need to simplify. If you've got 10x, add 2x. You've got 12x's. And positive 15, take away 8, would be positive 7. So question 3, and here we've got some times, 45 minutes and 3 hours 45 minutes, and they're in the ratio, or we're looking for the ratio 1 to n. Now the problem to start with here is we've got mixed units. So what I'm going to do is change 3 hours and 45 minutes into minutes only. So 3 hours is 3 lots of 60 minutes, 60, 120, 180 minutes, plus the 45, that's going to be 180, add 45, 225 minutes. So what we've got now is 45 minutes to 225 minutes, and I'm going to try and write that in the ratio 1 to n. So I'm looking for a 1 down here. In order to turn this 45 into a 1, I'm going to divide by 45. And if I'm going to do that to one side of the ratio, I need to do that to the other side of the ratio. So that's what I'm looking for. I'm going to do 225 divided by 45 as a fraction. And what I'm looking to do is simplify this division. Well, I know that 45 divides by 5 to give me 9. 225 divided by 5. Well, the 25 divided by 5 is 5. And the 200 divided by 5 will be 40. Right, 5 40s is 200. 5 5s are 25. So that is 45. We've now just got to do 45 divided by 9. Well, 45 divided by 9 is 5. So my ratio in the form 1 to n is 1 to 5, and n equals 5. Part B says Reese and Sarah share some money in the ratio 9 to 16. Reese says that Sarah gets more than 60% of the money. Show that Reese is correct. So I think Sarah is going to get 16 parts out of all of these parts. And 9 add 16 is 25. So Sarah's getting 16 parts out of 25 parts. We're looking to turn this into a percentage. Best way to do that is get your fraction out of 100. Well, I know that 25 times 4 is 100. So I just need to do the same to the top. 16 times 4. Well, 16 doubled is 32. Doubled again is 64. And 64 out of 100 is 64%. Reese is correct. Some cards with numbers on them. Someone's taking a card, replacing it, taking a second card and adding the numbers and then keeping a record. And this is the table that she can create to show the results. And we can see that 2 add 2 is 4, 3 add 2 is 5. We just need to complete this table. So I'm going to do 5 added to 2, which is 7. 3 added to 3 is 6. And 2 added to 5, that is also 7. Part B, we're looking for the probability of an even number. So I need to find all the even numbers in this table. So I'll just quickly go through my even numbers, picking out the ones that are in the 2 times table effectively. They're all the numbers that are in the 2 times table, so let's just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And a probability is a fraction out of how many things altogether. Well, if you count these up, there's 1, 2, 3, 4, 5, lots of 5. It's going to be 13 out of 25. There are 25 possibilities altogether. Part 2 says, what is the probability of a multiple of 3 or 4? Well, this just means we're looking for numbers in the 3 or the 4 times table. So let's find those. I'll just put a little dot in those ones. 4 times table. 4 times table. I'll do 4 times table first. 4 times table there and there. Yep. So they're my 4 times table. If I just go back through and look for the multiples of 3 or the 3 times table. There's 1. There's 1. And there's 1. I've already counted this, so I'm not going to count it again. Let's just count up these dots now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it's 13 out of 25. Question 5, and we've got an absolute madness fraction question, but we're going to do it anyway. Someone's writing these things for us. Charlie drinks a third of a carton every day, and Jasmine drinks 2/5 of a carton every day. Any apple juice left over is used the following day, okay? And they do that for 10 days. I think what I'm going to do first is figure out how much juice they need for 10 days or how many cartons. So if Charlie drinks a third and Jasmine drinks 2/5, if we add those together, we can figure out how much juice they drink between them each day. To add fractions, we need common denominators. So 3 times 5 is 15, and we're going to work in 15ths. I multiplied this 3 by 5, so I'm going to multiply the 1 by 5. I multiplied the 5 by 3, so I'm going to multiply the 2 by 3. And if we add those together, 5/15 and 6/15 is 11/15. We drink 11/15 of a carton every day for 10 days. So I'm going to multiply 11/15 by 10. And if you're multiplying a fraction by a whole number, you just multiply the top by the whole number. So 10 times 11 is 110 15ths. So that's how much juice we drink over the 10 days. Now I'm going to change that to a mixed number so we can see exactly how many whole cartons they drink. So how many 15s into 110? I'm just going to count up in 15s. 15, 30, 45, 60, 75, 90. That would be 105. So that's 1, 2, 3, 4, 5, 6, 7. And then there's 5/15. I got to 105 there, and I was aiming for 110. So that's why there's 5/15 left over. So this is the number of cartons that they drink. Now, obviously, we can't buy 5/15 of a carton, so that's going to be 8 cartons. We just need to figure out how much this is going to cost them. Well, if we have a look, the cost of a carton is 70p. So we need to do 8 multiplied by 0.7. Well, I'm going to do 7 times 8, which is 56. If we want to do 0.7 times 8, dividing by 10 in the calculation, so dividing by 10 in the answer, it will be £5.60. Got information about a clock that chimes every 20 minutes. We've also got a light that flashes every 8 minutes. We know that they flash together at 8 o'clock. And then we're asked how many times between 8:01 and 12:30 do they chime and flash together, and we must show us working. It is a bit of a monster, this, but it's worth 5 marks, so worth doing. Let's look at the clock first. I'm just going to start writing down times from 8 o'clock. So we know 8 o'clock is when they first flash together. So be careful with this one. We're going to keep just counting up in 20 minutes. So 8:20. 8:40, 8:60, 60 minutes in an hour would be 9 o'clock. I'm going to keep adding on 20 minutes to these times. Then I'm going to stop at 12:20, because if I went to 12:40, that's after this time, so I'm not interested in that. Now I'm going to look at the light. And again, I'm just going to start listing times. Remember, we already know that they've flashed at 8 o'clock, so I'm not interested in this one because I'm actually starting at 8:01. So I'm just going to start adding on 8 minutes here. And at 8:56, I need to add on 8 minutes. So 4 minutes will take me to 9 o'clock. And then 4 minutes after that is the total 8 minutes. That will be 9:04. This is a bit monstrous, listing all these times going up in 8 minutes. So I'm going to stop here and see if I can figure out how many times they chime and flash together based on what I've written. Remember, I don't want this one because I'm meant to be starting at 8:01. So let's just find some matching times. I think 8:40 is the first matching time. Then we've got 9:20. Then we've got 10 o'clock. And I'm not going to go any further with these times because I can see there's a little pattern. If we've got 8:40, then we miss a time and there's a repeat. Miss a time and a repeat, and that's going to continue. Miss a time, that will be a match. Miss a time, that will be a match. Miss a time, that will be a match. The pattern will repeat itself. So we've got 1, 2, 3, 4, 5, 6 times that they will chime and flash together. So question 7, we've got 4 congruent triangles. That just means they're exactly the same. And we've got 2 coordinates. And what we're looking for is the coordinates of these 2 points here. So let's have a look at what we've got. We know that this point is across to 4 and up to 9. So if this point here is 9 high on my y-axis. If we move across to this point here, we're coming all the way across to 17 and up to 12. So this point is 12 high. And if we go from 9 high up to 12 high, then we know that this distance must be 3, the difference between 9 and 12. So what I'm going to do is mark 3 on anywhere where I see the bottom of one of these triangles. So that's 3. And that's 3. The triangle is 3 across at the bottom. What we also know is that B here is across to 17. So someone's come all the way across to 17 to plot point B. And what we don't know is this distance. But we do know that here we've come across to 4. So we're starting at 4 and we're moving across 3. That would take us to 7. Moving across another 3, that takes us to 10. So at this point here, we're across to 10. And from there to here, we're going across to 17. So actually this distance is 7. And I'm going to do the same thing I did with the 3. Put a 7 anywhere I've got the height of that triangle. What we're looking for now is the point C. Well, C, I'm going to start at 4 and move across 3, 3, 7 and 7. So this point here starts at 4, 5, 6, 7, 8, 9, 10, 17, add 7 would be across to 24. And I know it's in line with A, so it's only as high as A. So that's 24, 9. Part D, well, we can figure out how far across we come. If we come across to part A again, we're starting at 4 across. We're adding on 3, adding on 3. So I know 4, 5, 6, 7, 8, 9, 10. I'm across to 10. And I just need to figure out this height. Well, again, I'm going to use A to help me. A goes all the way up to 9. I'm going to scooch across. I know that this measurement is 7. And I started up at 9. So 7 take away 9. Sorry, 9 take away 7 would leave me at 2 high. Question A, and we've got a probability tree. And we're just looking for the errors in this probability tree. So the first statement says the probability that it rains on Monday is 0.55. Monday rain 0.55, that's fine. I might just want to check these two branches and I can see that 0.55 added to 0.35 only comes to 0.9. So there's the first error. These branches need to add to 1. So I'm just going to write that down. Second statement, it says the probability it rains on Tuesday is 0.25. So we've got Tuesday rain and they've said 0.75. So they've got these branches mixed up. So I'll just write that down. And then third thing that's wrong with this diagram is we've not got these branches down here. We should have rain and no rain down here, following on from no rain on Monday. So I'll just put that down. And there's your 3 errors. Okay, so question 9, we're looking at a parallelogram. This line here is literally telling me that we've got a parallelogram here. And what we're trying to prove is the angle DAB, so from D to A to B, this angle is the same as BCD, from B to C to D. Now these are actually quite easy, and they're so easy that they actually feel hard. Alright, so just bear with me. This is what we need to do. What we're doing is actually proving congruence. So what we can say to start with is AB equals DC. So I'm just going to write that down. AB equals DC, and I'm going to write a reason. And that's enough. It's given in the question. I'm going to look at another straight line here, and it's this one. And I'll say that BD equals BD. I'm kind of looking at this line twice. And the reason that that's the same is because it's a common side. What I'm effectively doing is looking at these two triangles, this one and this one. So I've said that I've got two triangles with two sides the same, this, this, this and itself. And all I'm going to do now is look at an angle in those triangles. And if we look at this angle and this angle, we can say CDB equals ABD. And there's a reason for that. Alternate angles are equal. What we've done in those three statements is say that this triangle is the same as this triangle. We've proven that the triangles are congruent. So I'm just going to write that down. So triangle BDC is congruent to triangle ABD. And the reason is side angle side. And if you've got congruent triangles, then automatically those angles match each other. They're the same angle. So we can just finish the proof by saying that. Therefore, DAB equals BCD. So question 10, we've got a percentages question. And it's actually a reverse percentage question because what we've got is some information about percentages and then we've got like the answer or the amount after percentages have been applied. This first line says on Friday she took 50% less time than on Thursday. So that is going to be where we're starting. We need somewhere to start and we're going to start and say that Thursday is 100%. That's the initial amount if you like. And then back to this first line, it says on Friday, she took 50% less time than on Thursday. So Friday will be 50% less than this. Well, 50% less than the 100% is 50%. The second line says on Saturday, she took 20% less time than on Friday. So I need 20% less than this. So I need to bring this 50% down by 20%. And if we look at that and say 10% of this 50% divided by 10 will be 5. And what I can do then is say, well, 20% of 50% is just double this, which is 10. Be careful, it says 20% less time, so I need to remove this 10 away from this. And that's going to give me Saturday's figure. So I'm starting at 50%. I'm coming down by this 10, which is actually 10%. I'll land on 40%. If you like, I've knocked off 20% of 50%. And this here is Saturday. And what we know is that on Saturday, she takes 36 minutes. So on Saturday, we've got 36 mins. If I just rewrite that up here, we know that 40% is 36 minutes. We can now scale this down to 10%. Just divide by 4. And 36 divided by 4 is 9. And when we've got 10%, we can go back to 100%, which is Thursday's time times 10 times 10. You've got 90 minutes. So Thursday's 100% time is 90 minutes. Question 11, we've got to look at 16 raised to the power of negative a half. Well, we'll deal with the power of a half first. 16 to the power of a half is the square root of 16, not half in it, square root in it. And the square root of 16 is 4. 4 fours are 16. So we've dealt with the power of a half. Now we just need to deal with the power of negative 1. 4 raised to the power of negative 1 is just 1/4. Raising to negative 1 just puts 1 over your number. Simplifying root 6 times root 3. Well, 6 3s are 18. So root 18 is where you would start with this. We can simplify this further because root 18 is root 9 times root 2. 9 2s are 18. And the square root of 9 is 3. So rather than root 9 root 2, you've got 3 root 2. Question 12, and we've got the price of a car being £20,000, and it says it's expected to decrease by 5% each year. And Jasmine says that it's expected to be 18,000 after 2 years. And she's made a mistake. We just need to explain what's happened. So let's have a look what we think she might have done. If we look at 10% of 20,000, well, that's going to be, just divide this by 10, £2,000. That means 5% is £1,000. And because 2 years have gone by, what Jasmine has done has just said, okay, let's take 20,000, take away 1 year's worth, take away another year's worth, and that's how she's got down to 18,000. So what she's done is worked out the 5% once and taken it away each year. What she's done is called simple interest or depreciation. And that's not what's happening with the price of this car, because what happens is after 1 year, the car goes from 20,000, we take away the 5%, and we're left with 19,000. But in the second year, we have to work out 5% of this new amount and remove that. So I'm going to do that now. So 10% of 19,000 is, just take a zero off once again, divide by 10, 1,900. That means 5% is half of 1,900 is 950. So after the second year, we're going to do 18,000 take away 950, and that's going to come to 17,050. Part B says write a formula for P, which is the price of the car, in terms of N, where N is the number of years. Well, this is just your compound interest formula. So the price of the car is going to be the £20,000 that we start with, and we're going to multiply it by something. Now, if we're removing 5%, that means there's 95% left. And in order to find 95%, you'll multiply by 0.95. And we're told to do this for n number of years. So we're going to raise to the power of n. Final part of this question says circle the graph that best represents the price of P. Well, we're not coming down in gradual amounts. That would be the error that Jasmine made. We're not coming down slowly and then quickly. What happens with this kind of formula, we come down quite quickly and then less and less and less quickly over time. So that is the correct graph. Question 13, we've got to Noah's graphs here. So we're looking to draw y equals sine x between 0 and 360. Well, y equals sine x will always be between 1 and -1. And we get this periodic wave. So show you what it looks like. Might be a bit sketchy this, but I'm aiming for there and I'm aiming for there. We get something like this. There you go. That's y equals sine x. Just need to know that graph. Part B is talking about the graph of y equals, not y equals cos x, but y equals cos of x minus 30. What I'm going to do first is draw y equals cos x. So y equals cos x looks like, let me just get where I'm aiming for. Something like that. So y equals cos x looks like this. Y equals cos x. And what we can see from y equals cos x is it crosses the x-axis here and here. So I'm looking at 90 degrees and 270 degrees. Now when you've got something like this, y equals cos of x minus 30, what this actually does, because you've got a minus 30 in the brackets, that's actually going to push y equals cos x that way by 30 degrees. It's the opposite direction to what you might think. If you've got minus 30, we're going 30 degrees in the positive direction. So I'm going to add 30 degrees onto that, add 30 degrees onto that, and it will cross at 120 degrees and 300 degrees. Question 14, we've got some index work to do, so we're just going to multiply the 4 by the 3 here, and 4 times 3 is 12. And then we've got a to the power of a half multiplied by a squared, and when we're multiplying these we need to add the powers, so you get a, 2 added to a half is 2.5, you could have written 2.5 there if you prefer. Part B, again, just your laws of indices, but we've got some brackets. This cubing needs to apply to everything inside the bracket, including that 2. So 2 cubed is 2 times 2 times 2 again, which is 8. A squared cubed, we multiply the 2 by the 3. So you get a, 2 3s are 6. And then this a to the negative 3 also needs cubing. I'm going to do that just by multiplying these together. Minus 3 times 3 is minus 9. What we can do is actually simplify this further. This here is just a division. And when you're dividing like powers, you subtract the powers. So we've got a to the 6 divided by a to the minus 9. 6 take minus 9 is actually 6. Add 9, which is 15. So these a's simplify to a to the power of 15. And you're left with 8a to the power of 15. In 15, we've got a equation to solve, and we've got an x plus 6 down on the bottom of this fraction here. So first thing I'm going to do is multiply both sides by x plus 6 to get rid of that. And if we do that, we're left with just x on the left hand side. And because I'm multiplying by x plus 6, I need to put that x plus 6 into brackets. I'm going to expand this bracket on the right hand side. So we've got x equals 5 times x is 5x, and 5 times 6 is 30. Now what I've got here is x's on both sides. So I'm going to get my x's all onto the same side of the equation. So let's take 5x from both sides. And we end up with x take 5x equals 30. X take 5x is minus 4x. Could have just done that straight away. Minus 4x equals 30. We've got one more step. We're going to divide both sides by minus 4. And we're left with x equals minus 30 over 4. Don't matter where you put that negative, top or bottom, still the same. And negative 30 divided by 4. Well, 30 divided by 4 is 7.5. So we end up with minus 7.5. Question 16, we've got masses have been recorded of some parcels, and here they are. Jack's created a group frequency table to record the masses, and we need to say why it's not very good. Well, if we look here, you can see straight away we've got overlapping intervals. If there is a mass of 5, does it go into this group, which is including 5, or does it go into this group, which is also including 5? So the reason it's unsuitable is he's got overlapping intervals. Part B wants us to work on the histogram, so I've just copied that into this screen so we can see both at once. It says show 70 students took between 45 and 70 minutes to complete the race. So I'm looking to turn the histogram back into a frequency. The way we do that is by looking at the areas of these bars. So for example, in this bar here, if I work out the area of that bar, it will tell me how many people in this zone. So the area of that is, well, it's 20 wide multiplied by 2 high. That is 40 people. And I can do the same for this bar. The area is, it goes from 40, 45, 50, 5 wide multiplied by 6 high, and 5 sixes are, so that's 30 people. This is my 45 point that I'm looking at up here. So from 45 up to 70 is 30 added to 40, and 30 add 40 is the 70 people that they're talking about in the question. Part 2, calculate an estimate for the mean time taken and show your working. The nicest way I think to do this, to turn this back into the table that we looked at before. So I'm going to quickly sketch out what a table should look like for this. And you can see I've already put the frequencies, the amount of people that I just worked out in the first part of this question. All I need is these two frequencies, which are going to come from these two bars. So area here is going to be 5 wide multiplied by 4. 5 times 4 is 20. And that first bar, well, that's 10 wide multiplied by 1 high. That's just 10 people. Now I've got my class intervals and my frequencies. This is just mean from a grouped frequency table. So what I need is the midpoint of these class intervals. Well, midway between 30 and 40 is 35. Midway between these two is 42.5, 47.5, and 60. This is a non-calculator paper, but I should be able to multiply these together. So 10 times 35 is 350. 20 times 42.5, well, if I just double this, I'm going to get 85. So timesing it by 20 would be 850. It's a bit more difficult. I've got to do 3 lots of 47.5 and then times that by 10. So I'm just going to work over here. If I do 3 times 7.5, well, 2 of those would be 15. Add on another 7.5 is 22.5. I need to do 3 times the 40, 4, 8, 12, so that's 120. So I'm going to do 120 added to this, which comes to 142.5. And that's just multiplying by 3. So to times by 30, I'm going to times this by 10 and get 1425. Just put a separator in there. And then finally I've got to do 4 sixes with 24 and then 2 zeros on the end. So 0, 0, 2, 4. Final calculation for the mean. I need my frequencies added together and I need these added together. So let's do that now. That comes to 5. 5, 10, 12. 8, 9, 10, 11, 15, 19, 20. And then 2, 3, 4, 5. So I've got 5025 there. Add my frequencies, 10, 30, 60. That's nice, that's 100. So all I've got to do is 5025 divided by 100, which is 50.25. Question 17, we've got a graph and we've already got 2 lines have been drawn on as graphs. So we've got y equals x, which is that one. Y is the same as x everywhere. And if you have a look, we've got an inequality that almost matches that. Y is less than or equal to x. We've got y equals -2, which is this one. And again, we've got an inequality that kind of matches that. Y is greater than or equal to -2. The only inequality we've got that hasn't been drawn is this one. So I'm going to draw this straight line graph now. We're going to look to plot y equals 4 minus 2x. It doesn't matter which x values I use as long as they're in this range. So let's choose x is 0, 1 and 2. And my y value is going to be 4, take away 2 lots of x. So my first y value is going to be 4, take away 2 times 0. Well, 4 take 2 times 0 is 4. My second y value is going to be 4, take away 2 times 1. Well, 4 take away 2 times 1 is 2. And then my final y value is going to be 4, take away 2 times 2. And 4 take away 2 times 2 is 0. These are now the coordinates that I'm going to plot. So I'm going to go across to 0 and up to 4, across to 0, up to 4, across to 1 and up to 2, across to 1 and up to 2, and across to 2 and up to 0 will be there. Connect these with a straight line and keep going. What you'll find in most questions like this is you get a nice little triangle in the middle of your diagram, and that is usually the region that we're looking to shade in or label. We must just check that that's the right region and we've not got something else. So let's just have a look at my straight line graphs again. If this is y equals x, then pick any point on this side and just check, is y smaller than x? Well, this is the point 4, 3. And y is smaller than x. So I'm definitely on that side of my line. Let's look at the red line that says y equals -2. Well, again, let's just pick a point above it. Look at the coordinates. This is the point 4, -1. And I just want to check, is y greater than -2? Is my y bigger than -2? Yes. So I definitely want to come upwards on this line. And we can do a final check. I don't think it's necessary at this point. But if we pick any point on this side of my line, because that's where I'm looking to come for the region, this is the point -1, 3. And I'm looking to check, is y less than 4 take away 2 x's? Is 3 less than 4 take 2 times -1? 4 take 2 times -1 is 4 take -2, which is 6. And yes, 3 is less than 6. So that's definitely my region that I should have labelled. Question 18, we've got a triangle. It's non-right angled. It talks here about an average of 2.5 kilograms of carrots have been harvested from each square metre. This is telling you to work out the area of the triangle. So because it's non-right angled, I'm going to use area equals a half AB multiplied by the sine of C, where the two sides are A and B, and C is the angle between those two sides. Now we've got to substitute numbers into that, so that's a half multiplied by 80 multiplied by 100, and we're expected to know that the sine of 30 is a half. So sine C becomes sine 30, which is just a half. Now we've just got to work this out. So we'll do the 80 times 100 first. 80 times 100, well, 1 times 8 is 8, and then we've got 1, 2, 3 zeros on. And then we're going to do a half times a half, and a half times a half is a quarter. So all we need to do here is a quarter of 8,000, which is 8,000 divided by 4, which is 2,000 square meters. Back to the question, it says an average of 2.5 kilograms of carrots for each of these square meters. So we need to do 2,000 multiplied by 2.5. Multiplying by 0.5 is just a half. So we're going to do 2,000s. And we're going to do 0.5 times 2,000, which is just a half of 2,000. And add those together. 5,000, just 2 and a half 2,000s. So it's 5,000 kilograms of carrots in 2019. Part B says, why might this be unreliable? And we could just say something along the lines of different growing conditions each year. You could have had a really rainy year, a really sunny year. We don't know what actually happened. Question 19, and we've got a quadratic, and someone's telling us to write it in this form. And what they're saying when you've got that form is to complete the square. This is completed square form. So let's do that now. Completing the square is a single bracket squared. We're going to have an x in it. We're going to take this negative 10 and half it, so you get minus 5. You need to then square this 5. 5 5s are 25. And subtract it. Always this thing squared, then taken away. Don't forget the plus 22 on the end. Then we can just tidy all this up. We've got x minus 5 all squared. Minus 25 plus 22 is minus 3. Part B asks us to sketch the graph of the quadratic that we've just completed the square on. Well, whenever you complete the square, that provides you with something called a turning point. And what you're going to do is reverse the sign of this number in your bracket. So negative 5 becomes positive 5. And we keep this as it is. So we get the turning point, which is 5, negative 3. So I'm kind of just going to guess whereabouts that is. Let's say across to 5 and down to negative 3. That's going to be the turning point of my graph. If we look back at what we've been provided here, this number 22 on the end actually says where this graph crosses the y-axis. So this graph is going to cross the y-axis at 22. So we know where the graph crosses the y-axis. We know where the turning point of the graph is. The fact that it's a positive x squared graph means it's going to look like that. So we just need to come down through that. It's going to bottom out at the turning point and bounce back up. Must be a U shape. Must be a curve at the bottom, not a flat bottom, and must pass through 22. Question 20 of this exam, we've got a trapezium, and we're told that the perimeter is 56 centimeters. So all the way around this edge, 56 centimeters, and we've got ratios of the sides of 5 to 12 to 6 to 5. So what we're going to need to do first is divide the perimeter into this ratio to get individual side lengths. So all I'm going to do first is add these ratios together. So 5 add 5 is 10, add 12 is 22, add 6, they come to 28, and I know the perimeter is 56, so I need to do 56 divided by 28, and 56 divided by 28 is 2. So each part of this ratio is worth 2. So to find out the side lengths, I'm going to do 5 times 2, which is 10. 12 times 2 is 24. 6 times 2 is 12. And then we've got another 5 times 2, which is 10. So they're the side lengths of my trapezium. We're actually asked to find the area of the trapezium, and in order to find the area of a trapezium, you actually need this distance, the perpendicular height of the trapezium. So I'm going to try and figure out first what that measurement is there. Well, if I create 2 triangles, and we know that this is an isosceles trapezium because these lengths are the same, then that measurement will be the same as that measurement. And if the whole thing is 24 and this top bit is 12, then I must have a 6 and a 6. It's only because these side lengths are the same that I'm allowed to do that. What I'm going to do now is look at just this triangle on its own. We know that that measurement is 6. This is 10. And what we don't know is the height of the triangle. Well, this looks like Pythagoras' theorem. So A, B, and C, this is a right angled triangle. We'll write A squared plus B squared equals C squared. Substitute numbers into this. A squared plus 6 squared equals 10 squared. A squared add 36, 6 6 is 36 equals 100. A squared must be 100, take 36, which is 64, meaning that A equals 8. So the height of this triangle is 8. We're now ready to work out the area of the trapezium, so I'll just sketch it out over here. We know it's 12, 24, and 8 high. And the area of a trapezium is these two sides added together. So 12 add 24, then divide by 2, and multiply that by the perpendicular distance between them. So 12 add 24 is 36, divide that by 2 is 18. We need to do 18 multiplied by 8 in order to finish this question. So I'm just going to use a column method to do that. 8 times 8 is 64. 8 times 1 is 8. Add the 6 would be 14. Area of the trapezium is 144 centimeters squared.